Hello students, welcome to today's session on Introduction to Control System. In this session, we'll focus on fundamental concepts on control system, specifically understanding open loop and closed loop systems and how these concepts apply to our domain of biomedical engineering. We will also explore some interesting examples on control system in the human body. So let's start. So the content of this particular video will be, first we will discuss about the basics of control system, then we will see what are the different types of control system, and then we will have a comparison of open loop and closed loop control system, and then we will see few of the examples of bio control systems. So how we can define a control system? So basically a control system is a mechanism that manages, commands, or regulates the behavior of other devices or systems. And if we see what are the basic components of an control system, so the basic components includes a input signal, a process, or sometimes also it is known as plant that we want to control, and the output. And some systems may also include a controller and a feedback loop. So for example, let's say a simple heater controlled by a thermostat is a control system. And nowadays, with the advanced technologies, we can also make it as a open loop or convert it as a closed loop system also. So we will soon see how similar principle apply to biological systems like body temperature regulation. The control system can be classified broadly into different types based on how they operate and interact with their environment. The most common classification, as we will focus on today, is open loop and closed loop system. So in open loop system, the output does not influence the input. That means there is no feedback or there is no correction mechanism. So for example, in a microwave in our household, the oven heats food for a fixed time. Whether the food is heated properly or not, it doesn't matter. So it is a very basic and simple example of open loop control system. In contrast, if we compare the closed loop control system, it uses the feedback. That means the output is measured and compared to the reference value, and the system adjusts its input as per the difference of reference value and the current output value. So a very simple classic example in the air conditioner with the thermostat that maintains room temperature at a desired set point. So further, if we classify the control systems in different other domain, so we can say the control system can be a manual or automatic control system. So simple, the manual control system, that means it involves a human operator or human intervention while making a decision based on the observation. So let's say if a person is driving a car by his own or her own, that is a example of manual control system, or a nurse manually administrating a drug based on patient feedback or vitals. That means that my nurse is checking out the vitals of a patient, and based on that, the nurse is deciding how much drug should be given. So this is the example of manual control system. And then the automatic control system. The automatic control system operates without human intervention. That it doesn't need any human intervention. All it depends on the sensors data and the controllers. So for example, a ventilator that automatically adjusts airflow based on a patient's breathing pattern. So the sensor will be used to measure the breathing pattern, and based on that, it calculates the airflow and it calculates the desired or the needed airflow. Based on that, the corrective action will be taken. The other type of classification of control system can be single input, single output, that is SISO system. or the other one is multi-input, multi-output MIMO control system. So the single input, single output system, as the name suggests, these systems have one input variable and one output variable. So for example, an infusion pump that delivers a fixed dose of medication based on a single control input, let's say the flow rate. That means the flow rate of the drug given by the pump is actually um, depending upon only one variable, that is the flow rate. Then the other type of control system is multi-input, multi-output, that is MIMO control system. So these systems involves multiple inputs and multiple outputs. So these systems are comparatively more complex and little difficult to implement. So the example for this multi-input, multi-output system can be, let's say, an anesthesia machine that regulates multiple gases and monitors several physiological parameters like heart rate, oxygen saturation, and CO2 level at once. So that means there are multiple sensors which are measuring the heart rate, oxygen saturation level, that is SpO2 level, and the CO2 level. And based on that, the system is deciding which type of gas should be more or which type of gas should be less in the anesthesia machine. So this is an example of multi-input, multi-output system. Likewise, the other classification can be linear or non-linear system. So the linear systems obeys the principle of superposition, that is the additivity and the homogeneity. So very basic example of linear system is electrical RC network that normally we used for the signal filtering. In the same way, the non-linear system do not follow the linearity principle and their behavior is more complex and realistic in nature. The example of non-linear systems can be human cardiovascular system where blood flow dynamics are non-linear due to vessel elasticity and different resistance, or we can say the varying resistance. So these are some of the examples of different types of control system. Now we will focus on the open loop control system. So, as we already discussed in our previous slide, an open loop control system is one where the output has no effect on control action. That means the system does not measure or correct the output based on its behavior. So, a common basic biomedical example would be a fixed dose insulin injection. That means the patient injects insulin based on routine, not current glucose level. The system does not monitor whether the output blood sugar level has been corrected or not. So the advantage of these systems are that it is simple, cost effective, but it lacks accuracy and adaptability. The other type of control system, that is closed loop control system, it uses the feedback. The output is constantly monitored and system self-adjusts to maintain the desired result. In a biomedical context, if we say, we can think of a artificial pancreas. It sends glucose level in real time and automatically adjusts insulin delivery. This makes the system more intelligent and responsive, but also more complex and expensive. Many of our body's physiological processes operates a closed loop system for survival and homeostasis. Now, if we compare, now we know most of the aspects of our open loop and closed loop system. If we compare, so the open loop systems are simple, cost effective, but can't handle disturbance or variability. Whereas the closed loop systems are more accurate and robust, but they need sensors and processing, which makes them more complex. So for example, measuring blood pressure manually is an open loop system, whereas an automatic blood pressure monitoring system, which inflates, sends, and stops, is a closed loop system. And we know both the systems are having their place depending upon the application. So we can't say that open loop system is better and the closed loop system or vice versa. It all depends upon the application and the usability. Now let's connect this to biology. The human body is full of different closed loop control system. For example, in thermoregulation, the hypothalamus, that is one of the brain part of our uh, body or brain, it acts as a controller. It detecting the body temperature and it triggers the sweating or the shivering. In a similar manner, in our body, in glucose control, insulin and glucagon are used by the pancreas to maintain the homeostasis. Whereas similarly, in respiration, the CO2 levels are sensed by the chemoreceptors and the brain stem adjusts breathing rate accordingly. So these systems are some of the very basic, simple or elegant examples of how our body feedback maintains stability in the body. So now we can summarize that a control system manages outputs using input and sometimes the feedback. Like in open loop systems, it works without feedback and are simple, but its applications are limited. The closed loop control systems uses feedback for better accuracy and the stability. So understanding these concepts are essential, not just in engineering, but also in understanding the human body and designing biomedical devices. So thank you for your attention. In next session, we will move on to the next topic. Thank you.